thrive in those kinds of conditions, and that if humans
I
could,
think warming and low oxygen really favor jellyfish
yeah.
because they can store oxygen in their mesoglia, their jelly, and have a source.
So if we could get used to eating jellyfish, that could be a sustainable protein source. I tried it. I had a professor brought it in and they prepared it kind of like seaweed salad that you get in a sushi restaurant.
Yeah, I've tasted it. It's not that bad.
Yeah.
Put a little soy sauce or something on it, or?
Yeah, kind of like a wakame salad with soy sauce and sesame oil.
Do they make degradable rubber bands?
Yeah.
Are these?
They're natural rubber, so not synthetic rubber.
Good. Does natural rubber degrade? I guess it does.
Oh, it's a plant-based thing. I don't know how long it takes, but
It's great. These cores look beautiful. Thank you.
okay. So ready to put them away?
Yeah.
All right.
All right.
Who's up first?
NA124, 114, push core 8.
A little short.
We really need some music for a push course.
Not quite.
Is it a...
I think so. If anybody else would like some.
forward more?
Kira could sing. She likes to do that.
It's true. I do find myself singing, especially in the lab late at night when you gotta.
Again, it made me
mojo.
forget it.
I don't think audio is allowing singing today. That last one was 8?
The blue one we just put away was push core 7.
7.
Okay, thank you.
So
Okay,
they've done 8 already.
Yeah, okay. Sorry.
Thank you, Aaron.
Yep.
That is a nice looking core.
So for people watching, we really like it when the water on top of the sediment stays clear like that. It means the core is very undisturbed and the animals don't really know that they're not even in the bottom anymore. They continue doing their thing, and a lot of times when they come up on the ship, we can look inside the core and still see them waving tentacles and being in fauna.
Go to sleep, open your door, and then you're in some strange person's lab.
Then you're in ethanol.
Then you're in ethanol. Hey, that's the way
Or
to
for
go.
formalin. Yeah, they'd probably be happier in ethanol. So you can see 5 has
Sorry.
the sediment is a little cloudy, I think.
Can I rack the camera out to see it better?
Yeah, push the drawer out more.
Sure. Coming out.
That's good.
Okay.
Put it in there. What's happening?
It looks
Sorta.
good.
Get in there.
Yep, there.
So for people looking at the sediments, you know, the animals we see are sea cucumbers and fish and sea urchins. But what we don't see are the really tiny animals that live and feed inside the sediment. We call those macrofauna and myofauna. They're small invertebrates that might belong to a variety of different worm groups, polychaetes, nematodes, subunculans, enterobnus. So there's also some small mollusks and small crustaceans and small echinoderms under the sediment. So a typical density for a place like this might be 5,000 animals, small invertebrates per square meter for the macrofauna. So a core like this might have, I don't know, somewhere between 10 and 30 macrofaunal organisms. And many more myofauna. So myofauna would be nematodes, harpacticoid copepods, ostracods, and other small invertebrate groups. And they come in the thousands per core, hundreds per core, I should say.
Push core 4?
Yep.
118.
Caitlin's asking, what are the different size classes of fauna? For example, what's the difference between myofauna versus macrofauna? And are there others? What are microfauna?
Well, macrofauna, which is what our lab tends to specialize in, are animals retained on a 0.3 millimeter mesh or 300 micron mesh. So they can be pretty small, but they can be up to a centimeter, half a centimeter in size. The myofauna are animals that generally go through a 2 millimeter mesh, but are retained on a 42 micron mesh. Some deep sea scientists use even smaller mesh sizes, like 32. And they would include things like nematodes and harpacticoid copepods, ostracods, chinorhynchs, gnathostomulids, and other really weird invertebrate groups. And then the microfauna, I'm guessing, would be the ciliates and flagellates and even tinier protists that go through a 42 micron, and I'm not sure whether there's a bottom cutoff for them.
Was that green tape on push core too?
Yes.
All right, thank you.
You're welcome. Uno más.
What's interesting about these size classes of fauna, there's nothing magic about them because juveniles of macrofauna fall in the myofaunal size category, but people tend to assign different taxa to different groups where they dominate, and then that's what they study. So for example, we take cores, we sieve for macrofauna. If we find nematodes, which are considered myofaunal organisms, we may not count them because most of the nematodes have gone through our mesh.
It's operational.
It's kind of an operational size class.
Look at how the cucumbers have gone over to the holes.
Yeah, do you think they smell new deliciousness or
I think so.
something?
They're like, ooh.
Something got stirred up. I should go check that
It's a down core buffet.
out.
So Caitlin, sponges that we can see, we often call them megafauna. Megafauna tend to be anything that a centimeter or larger that you can see in a video, a camera, still camera image. But other people call megafauna the charismatic megafaunas, like whales, dolphins, it's like that. But
Nice job, Bob. You're a core pro.
thank you, Bob.
Welcome.
Bob, we trust.
Another 20-minute series. That's some remarkable.
Push the drawer in. Sample trays coming in.
Okay. All right, where to?
Our first waypoint.
So we were just on AA for that, so we'll be moving towards AB. So we'll be moving up slope. And it's going to be about 286 meters, bearing 273. So I'll start us out with a 50-meter step to get some motion on, if that's okay?
Yep.
All right, here we go. Bridge nav.
So we'd just like to be able to see the bottom, but we're heading for the rock.
We get a 50-meter step bearing 273.
Looks like a sponge with a large anemone on it, which we see often elsewhere. I've seen this right off San Diego. These depths, like a tulip sponge.
What's the heading?
273.
Thank you.
Yep.
I'm gonna turn the other way. Is it okay?
Yep.
Did anyone actually get stung from those siphonophores the other day?
No,
Mm-mm.
No?
they apparently aren't stinging types.
Oh,
It's a
that's
good thing.
disappointing.
It's a
They were
good thing they're
everywhere.
There
flying
would have been a
everywhere.
lot of miserable people if they did.
They were flying just
How,
absolutely everywhere.
how long did it take you guys to get them all off her?
Oh, they didn't come off.
There's
Oh.
still many on there.
I learned a new word, siphonophores.
Yep, it's a good word.
Good word, yep.
I'll be here all week.
So big crab, maybe it's a lithodid, maybe it's a tanner crab. We don't have Mary Wickstein on with us.
A lot of those
Headed way
pinnakia.
over there.
Hmm?
You're headed way up there. Almost. Maybe. Just so you know.
Hey.
Got a while before you have to worry about it.
Is it transect or are we just cruising?
We're just cruising. You can see the big stock sponge. Maybe Greg knows the name if he's down there. We see those at 700 meters all along the slope right off San Diego. And they often have those really large anemones attached to them.
It's a pretty big depth distribution then if we're seeing them all the way down here too.
Well, it's the same depth.
Oh, the same depth. I thought it
It's
was.
just, they seem to live offshore too. Oh, there's some sort of cnidarian. That. So the pink urchins, of which
zoom
there
in
are a
now?
lot, pink urchins are called Strongylus centrotus fragilis. They have a very broad depth distribution. So that looks like a dead sponge stalk with 3 anemones living on it.
Hey, zoom out.
Beautiful.
It is.
Looks like a
Pretty
little flower arrangement,
yeah.
doesn't it?
It's like
Mhm.
dahlias.
Yeah. One of those as above, so below things.
Yeah, the sea urchins are interesting because they can live here, they can live down at 1,100 meters, they can live up to 100 meters. They're really tolerant of low oxygen. Oh, look at something in a line.
Trail.
Yeah.
That's an interesting
Mhm.
setup.
Look at that.
I wonder if
Can you zoom in?
Gas
Can we
or
zoom in,
something.
please?
Is that a little ridge it's on?
It looks like a little depression or
Sponges?
mushroom. It looks like mushrooms, but I
yeah.
think they're sponges. Or maybe they're urchin
No, those sponges.
skeletons. They're
I think they're
sponges.
sponges.
Ooh, I wonder if we should get one of those.
do you want to explore a bit?
Can you zoom back out just so we can see, is this a whole line of sponges that have tuned into something here?
Bridge nav, hold position.
That looks
at
like
that.
a trail.
Looks like a trail of sponges. Sure, maybe we could section.
Yeah.
We got about 20 meters into that move, so you're going to...
I'm just not used to
Hold a
seeing
bit.
sponges on the sediment like that.
Okay, I'm going to move up the line a little bit just because we have a big move on.
I held it, but we got 20 meters, so you're going to get a bit of swing.
That's really interesting. Can't say I've seen that before.
Okay, so you want one
Yeah,
of you guys?
if you could section a few of those into
Okay.
one of the coarse mesh.
Okay. Which one are we going in?
If I'm not mistaken, one has like very coarse, super coarse.
It would be either 4, 5, 6, or 7.
Oh, okay, right. Opposite. It's very fine.
Yeah.
Number 1.
We want to avoid number 1, 2, and 3.
Okay, I gotta get the right view.
I mean, this is a lot of megafaunal size invertebrates that we're seeing down here. This tells us there's a lot of food incoming.
Do you need to flush it at all, or can I go straight to one that we're going to put it in?
I think you can just, well, go ahead. If you're on the flush, is that the
Okay.
flush? What is that?
Yeah, that's flush.
Yeah,
I mean,
just
you
go
guys
ahead and run
can
it
use
while you're
these
there.
sponges.
Okay.
Right? So how many should we get? So everybody can have a piece.
All right. I'll call that.
If we,
Yeah, quit sucking.
if
I
we
did,
It's,
I
it
did.
gets in the dirt.
I did.
It's in
Sorry.
the dirt. It's just sucking
see
up
if
more
they
dirt.
come up and not clog. Do they look like a decent
now.
size?
I'm going to zoom in
Yeah,
on one.
they should be able to be surfed pretty easy.
We're on slurp jar 7.
Slurp 7, thank you.
Ready when you are, Bob.
I'm ready when you are.
Okay, I'll turn
Golf
it
ball
on then.
size sponges.
There's actually some rock underneath there.
You think they're on rocks?
Yeah, that's not just dirt.
Oh, well, maybe they'll
Oh,
come
yeah,
up,
look
maybe
at
they
that.
won't.
Yeah,
Let's see if you can nudge them. So maybe they're living on rock, huh?
yeah, I think so.
Well, see if they'll nudge off the rock and go up the tube. Yep.
How many you need? That was 3.
You got 3? We could use about 5 or 6 of them if you can reach them.
Wow. Okay.
Jensen Lab can look at them.
Yeah.
Would you mind taking one of the stars too, please?
There he goes.
Is that the one?
Yeah,
Perfect.
Now.
Thank you.
that's 5 sponges, 1 star.
I didn't write anything down yet,
You didn't.
but we're on suction 7.
I think Paul didn't get a panicia for natural products, so a little one would be good. A little...
The one right in
600.
front of you?
Yeah, perfect.
That one?
It's a little circus in there.
And then
Is that too big?
I don't know.
I don't think so.
I think that might be too big.
That's all the beans,
Okay.
yeah.
I
Okay.
don't wanna clog the hose. Sponge ball.
SpongeBob.
I'll turn off suction.
Yeah, I'm gonna move up a little bit.
Did all of those fit into Slurp 7?
They all went
Yeah,
into
they're-
slurp.
They're not very big, most of them.
Yeah, they're probably that big.
All right, turn it on suction. Oh, I just saw that Pernicia. He's in the flush jar now.
You saw him?
Yep.
Yep. you sent that.
Okay, we got quite a few.
I'll leave a suction
you.
on for a second for them to...
Okay. You gonna zoom out?
Greg, do you remember the name of the big stalk tulip-shaped sponges that the anemones are growing on?
Oh, good question. Let me check my notes. Good
They're in
question.
the
Let me check my
manual.
notes.
What do you think? Call it good?
Yeah, what let it settle out and see what we got.
Okay, I'll turn this
I just
off.
saw the star. Sponges.
Can we look up the sponge in there?
It's like a snow globe.
It won't. Can I have the Monterey guide? Yeah.
Caitlin's saying that it looks like Saccocalyx.
No, it's not.
Oh.
It's Saccocalyx.
It is a little ocean snow globe, isn't it?
Uh-huh.
Yeah.
Did you see the sea cucumber in there somewhere?
I saw him before. I saw him when he came in.
Okay.
I don't know where he is now. Probably
It's this one.
traumatized somewhere. Just hanging out on top.
Possibly
Bad day.
Okay, you think we
Happy.
got all that?
I think so.
Yep.
Happy little slurp jar.
Cool.
Thank you.
That was 122, correct?
Correct, 122.
Okay, it's not in there. It's too bad. It's really common in this Southern California.
You guys want anything else from this area before we move again?
Nope, I think we're good.
All right.
Thank you.
You guys ready? Bridge nav.
Oops.
A 50 meter step bearing
Okay.
273, please.
Hold on. It's like something with the mouse when you do it fast. There you go.
Quite a bit of those urchins.
Lots of Strongylus and Trotus fragilis. We call them the pink urchin.
That's a mouthful.
And they are one of the most low oxygen tolerant taxa. We're right in the core of the oxygen minimum zone. So for people not familiar with that, this is an area with just a few micromolar of oxygen. It's so low because of productivity raining down and decaying mid-water, using up the microbes that decay organic matter, use up the oxygen. And these waters are also really isolated, so they haven't been in contact with the surface in hundreds of years. So this low oxygen is a feature that runs up and down the whole East Pacific, but off here it's at its lowest around 700 or 800 meters where we are now. There has been, one of my former students, Kirk Sato, was looking into whether these urchins might actually form a new fishery, a new sea urchin fishery, because they're more tolerant of our declining oxygen conditions than, say, the red and purplish urchins that currently are fished off Southern California. So again, this anemone, beautiful. It's not making the stalk. It's on a dead sponge stalk. And those sponge stalks can be a meter high or more.
Zoom in now.
You can see it coiled. It's made of silica.
Oh, that's really cool.
And apparently some of these have some interesting fiber optic properties that are being investigated, some deep sea sponges.
Looks like something from a Dr. Seuss book.
Yeah.
Lovely. I don't know the name of this anemone. Do you, Greg?
I love those colors. So pretty, delicate.
Okay, moving on.
One of the things that we found is that even though the urchins are abundant here and fairly happy. Their test, which is the calcareous structure that they live in, is much more porous and thin here because of the high carbon dioxide conditions. So the oxygen minimum zone is actually also a carbon maximum zone, and the pH is quite low here. And it's harder for them to calcify their test.
Zoom in on.
They also have lower reproductive rates in here where the oxygen's very low.
Ooh, what is that?
Creepy.
Looks like a
Not
snake.
sure what this is. An eel pout?
It's moving.
It's alive.
Snakehead eel pout. Right?
Snakehead eel pout? Is that a real thing?
Yeah, I think so. Isn't that what it is?
It's a
I
dirty one.
don't know. Steve tells us it's an eel pout, so that's right.
Bridge nav.
Cool. Goodbye.
Big eyes.
50 meter step 273.
Looks like a snake's head.
Yeah.
Erica Burton is
Had
saying, yes,
enough
that's
of
a
you.
snakehead eel pout.
All this time sitting here is worth something, I guess.
Now you're behind. Catch up, buddy.
I can do that.
Yeah, so there's the sea pens. We were commenting when we were at the patent escarpment before, we didn't see any sea pen. We had a lot of sea pens, and here we don't, but we just are passing over a couple. Here they come. Oh, more anemones.
They're cool anemone.
That one may have its sponge still alive.
All right, Abigail Powell is saying that the sponge stock we saw was a Hyalonema populiferum, the fiber optic sponge.
Cool.
Oh, so my comment about the fiber optics was not far off
He
here.
nailed it.
So what do you mean by a fiber optic sponge? Is it like a misnomer, or are they trying to use it for fiber optics?
Well, there's this whole field called bioinspiration, where natural phenomenon can be useful to people in various ways, and there are special light conducting properties of those sponge spicules, which are giant spicules made of silica. So I think that's why it's called the fiber optic sponge.
Very
I'd never
cool.
heard that name before.
Did you say the sicula or the spicula?
Spicula.
I'm writing it down so I
Spicules?
can Google it.
So I think that tulip sponge is, it's sometimes called a glass rope sponge or a tulip sponge, and it's called Hyalonema.
Okay. I have one in my lab. I should remember the name. Somebody commented we passed over Umbellula. I didn't see it. But Umbellula.
I do altitude also?
If you wanna.
Okay.
You have to take it off.
Oh.
That's stick lock.
Oh,
If you want auto altitude, it's that one.
okay.
Yeah, so Steve Vaskovich is telling us that the sea pens might be Halipterus or Funiculina sea pens that we're coming up on here. They just look like a single stalk sticking out of the mud, but a close-up look would show that they have tentacles with stinging cells. So there's an example on the upper right view of a hylonema with its sponge alive, you can just gone out of view.
I'm going. I'm going.
I think we may have missed it here.
It's right in front of
there.
us.
Oh, there it is. Coming into view.
It's like a little hat, chef's hat.
That's pretty
There,
cool.
there we go. So people can see what the sponge at the end of the stalk actually looks like. But the stalk lasts longer than the living part of the sponge, it seems.
Oi, oi, oi.
Beautiful.
I see why it's called a
When you
tulip
push the
sponge.
buttons,
Yeah,
push down.
yeah, I am.
You're pushing forward.
I
Don't
am.
push forward.
I was.
I know.
Do
No
it.
problem.
Video zoom.
Somebody inside, little crab.
Quite pretty.
Oops.
You can see it's good size based on our 10-centimeter lasers.
Do we
Can
want to
you
go
come-
tighter?
Can you come tighter? Yeah, please.
So tight I can go.
So Stace Beaulieu did a study on stalk sponges and all the things that live on them, and even after they die, they host a wide range of deep sea invertebrates.
Okay, come wide, please.
Might be all the way over.
We would call this a symbiosis because the sponge is providing the anemone habitat. It's getting it up off the bottom, which is probably a good thing. Stronger currents and less sediment clogging.
Your mic's not on, Logger.
What's the anemone providing for the sponge?
That's a good question. I mean, anemones have stinging cells that often can take out predators, but I don't know.
What's the slope here? What's the slope?
Very, very, very gentle.
To try to find balance.
I'll get pickier the longer you sit there.
Yeah, it's okay. That's cool. My driver's ed teacher was pretty picky too, so I got the skin for it.
Bridge nav.
So I would say
50 meter step 273.
I forget if we had a terrace at this depth at Site 4 or other patent escarpment site. Does anybody remember if we went over sediments like this at 700 meters?
I don't think so. Only in the beginning.
Yeah, at the beginning we were much deeper, 1,100 or 1,200 meters. This is what the oxygen minimum zone community is on soft sediments, I'd say. Should be coming onto steeper terrain soon. I don't know if we'll see rocks. I guess from what Bob said, the rock's right there. It's just got a thin layer of sediment over it.
Well, certainly where those sponges were.
Yeah.
Maybe that was just a line of rocks right there that they were on.
Ooh, you know, it could have been a whale rib bone.
We want to find one on our watch too.
Pretty long.
Bob, find
It
us
went
a whale
for-
bone.
I think that was too big for a whale bone.
Okay. What?
So about 140 meters off where we should start seeing some slope change. So not a huge change.
Looks like some more of the Helipterus sea pens, Strongylus centris fragilis.
Who's all curled
Thorny
up
head.
there? Is that just a sea
It's
cucumber?
a squirrel tail
Video zoom?
sea pen.
Is that a real thing?
That's what they were calling it
Oh, missed
last
it.
couple cruises. I don't know if that's its official.
Ah, that's pretty cool.
What is that?
Oh,
Is that the sea pen?
Yeah, they were calling it a squirrel tail sea pen. I don't know. You can see it looks like a squirrel's tail.
Steve is
I
saying
follow.
Anthoptilum grandiflorum.
I could see it.
Come wide video? Thank you. Should I tilt down a little more or no?
Yeah, a little bit. I mean, just clear that. Yeah, or you could have them zoom past those.
Thank
Yeah,
you.
there you go.
That was squirrel tail sea pen.
Anthoptilum grandiflorum. Or those little golf ball sponges. I think that's a Helipterus on the right, the sea pen.
I'm coming up.
Pretty close.
I'm coming up.
Map of the earth.
That differential between the back and the front gets me every time.
Oop.
Ooh, see him skirt away?
Is that eel powder?
Look at him go.
He skirted.
Bridge nav.
That was the most energy he's put out for 3 months.
Another 50 meter step at this bearing's good. I think area 270.
He's spent. He's like, I'm going to play dead right here. Oh, no, yeah.
Okay.
He's running out of poop, though.
I wonder if that's a defense mechanism, kicking up the sediment like that, so things can't.
We saw that with the flatfish. They would like do a figure S or 8 and stir up the sediment before taking off in a line.
You know, I've
Tricky.
seen sablefish do that too. Off, Northern California, I've seen them just dive bomb into the sediment and kick up a bunch, and people
Yeah.
in the subs and the ROVs have to sit there for half an hour and wait for it to clear. Look at that little pile of urchins up ahead. Usually it means they've found something that's dead. to eat. Sometimes they aggregate
no,
on
no, no, no,
kelp.
no.
It's like, I think it was like up.
She was going to put it down. Like,
Ow, ow.
yeah.
I'm following your nonverbal communication pretty well today.
Umbellula.
There's a lot of stuff right here.
Lots of panichias. Well, this is very characteristic of a low oxygen, high food environment where there'll be a very high density of organisms. And this is pretty high density for megafauna, but really low diversity. There's probably no more than 8 or 10 species here that are really common, and maybe 5 super common ones, like the sea urchin and the sea cucumber. I'm not sure what this white asteroid is either, but I've seen dense bands of them on directly on the margin off San Diego, but about these depths.